Welcome to one more session of maths for standard 10, and we are discussing chapter number 6, triangle. Okay, now my friend, we move to discuss the theorem, basic proportionality theorem, means theorem 6.1. And before we discuss the theorem, we have to learn a few things. Okay, we have to clear a few things. One of them is area of triangle is equal to half into base into altitude. Okay, altitude. See, this is a triangle, acute angle triangle, and this one is ABC, and this is the base altitude of the triangle, it's AM. Okay, so we can write area of triangle ABC is equal to half into base BC into AM. Okay, so there are three altitudes corresponding to different bases. Okay, we can also write the area of triangle ABC is equal to half into base AC into corresponding altitude, it's a BN. Okay, there can be the third one. Okay, so CN is the altitude of the same triangle on the base AB. So we can also write area of triangle ABC is equal to half into base AB into CO. Okay, now this is what about acute angle triangle. Now if we think of obtuse angle triangle, look at this, it's ABC. Okay, now in case of obtuse angle triangle, there can be an altitude which is out of, it's not inside the triangle, it is not interior to the triangle, it's exterior to triangle. So here also the base, corresponding base BC is here and altitude here. So we can write area of triangle ABC is equal to half into base BC into altitude AM. Okay, so this is the triangle, but my friend, area of triangle ABC can be written as half into base BC and into corresponding base AM. Okay, now one more thing we want to clear is that area of triangles on the same base and between same parallels are equal. Okay, area of triangles on the same base, look at it, there are two parallel lines. Okay, and this one is triangle ABC, this one is triangle EBC. So area, see, look at it, triangle ABC and triangle EBC are on the same base BC and between the same parallels parallels AE and BC, and therefore area of triangle ABC is equal to area of triangle ABC. Okay, if two triangles having same base and they are lying between the same two parallel lines, then their areas are equal. So these two things, keep these things in mind before we discuss the theorem. Okay, very good. Now theorem number 6.1, it's a basic proportionality theorem, BPT. It is also known as Thales theorem. Okay, Thales theorem. Now see, this is the theorem. If a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, then the other two sides are divided in the same ratio. Look at it. It's a triangle ABC. In triangle ABC, a line is drawn parallel to one side of a triangle to intersect the other two sides. Now look at it. This is a line parallel to BC, side BC of triangle ABC, and intersects AB and AC into two distinct points D and E. Okay, so this is what about the given in triangle ABC, a line parallel to BC, parallel to side BC, intersects AB and AC in points, rather at points D and E respectively. D and E respectively. Okay, D and E respectively. So ये लाइन इस ट्राइंगल ABC में एक लाइन है जो BC को पैरेलल है और बाकी की दो लाइंस AB और AC को दो डिस्टिंक्ट पॉइंट्स D और E में इंटरसेक्ट करती है. Okay, then we want to prove that what we want to prove that we want to prove that the other two sides are divided in the same ratio. See, the other two sides are AB and AC, and we want to prove that AB and AC are two sides, and we want to prove that they are divided in the same ratio. See, AB is divided into two line segments AD and DB, and AC is divided into two line segment AE and EC. So if the line divides two sides AB and AC in the same ratio, means what? AD, DB, AE and EC are proportional. Means what? We want to prove that AD upon DB is equal to AE upon EC. So that we want to prove. Okay, and for that we want some construction. For that we want some construction. Okay, what we want? We want to draw two perpendiculars. Okay. So here DM and EN. So EN, here draw DM perpendicular to AC, EN perpendicular to AB, then join BE and CD. BE and CD. Okay, we have to join BE and CD. Okay, now proof. Now my friends, we know that area of triangle ABC. See, area of triangle ADE. Area of triangle ADE. Now you can see triangle ADE. Okay, ADE triangle have. This is triangle ADE. It has altitude DM on the base AE and altitude EN on the base AD. Okay, so we can write that area of triangle ADE can be written as half into AD base AD into altitude EN. Okay. Now it can also, now think of the other triangle BDE. Look at BDE. BDE. Okay, it's an obtuse angle triangle BDE. Looking at the base BD, it has altitude EN here. Okay, so this is triangle is here, it's a BDE, and on the base BD the corresponding altitude is EN. You can see that EN is the altitude on base BD in triangle BDE. So area of BDE can be written as half into side DB base DB into altitude E. Okay, now if we take the ratios of both these results, so therefore area of ADE upon area of BDE is equal to area of ADE divided by area of BDE. So half into AD into EN divided by half into DB into EN. Look at it, half gets cut, EN gets cut, so it's AD upon DB. This is result number 1. Okay, this is result number 1. So taking the ratio of both these results, we come to the result that area of triangle ADE and area of triangle BDE are AD upon DB. Now my friends, similarly we can write area of triangle ADE in the different way. Now DM is altitude, so area of ADE can be written as half into, now AE is the base, half into AE, and the corresponding base altitude to AE is DM, so DM. Okay, now my friend, look at the other triangle DEC. Think of DEC. Here it is D, here it is E, here it is C. Now its altitude is outside. Here is the altitude DM. Okay, this is triangle DEC, and its altitude is outside the triangle. Now looking at the base CEC, the altitude is DM. So we can write that area of area of triangle DEC. Look at it, area of triangle DEC. Can you see that area of triangle? It's a triangle DEC. Its base EC and its corresponding altitude to EC is altitude DM. Okay, so area of triangle DEC can be written as half into base EC into altitude DM. And here also, if we take the ratio of both this, so area of ADE divided by area of DEC is equal to 1/2 cut, DM cut, it is AE upon AC, and this is the result number 2. Now my friend, think of this. What we want to prove? We want to prove that AD upon DB is equal to AE upon AC. AD upon DB is equal to AE upon AC. It is present here to the right hand side of both the results. Look at the result number 1 and result number 2. AD upon DB is here and AE upon AC is here. So if we want to prove them to be equal to each other, then we require to prove that their left hand side are also equal. If we are able to prove that their left hand side of result number 1 and 2 are equal, then it will be proven. So here our target is to prove their left hand sides are equal. Now think, numerator of both the results, area AD, area of AD are same. But the only difference is there is that denominator area of BDE and area of DEC. Area of triangle BDE and area of triangle DEC. That is our target to be proven to be same. Now my friend, look at it. DEC, look at it. It's a BDE. Triangle BDE and triangle DEC, isn't it? Can you see that? Both these triangles BDE and DEC. Look at it, both the triangles are on the same base DE. दोनों उल्टे हैं, लेकिन both the triangles are on the same base DE and both lie between the same parallels. DE parallel to BC, because DE is parallel to BC, that has been taken here in the given. So both these triangles are lying on the same base and between the same parallels, and that's why their area are same. So we can write that triangle BDE and triangle DEC are on the same base DE and between the same parallels DE and BC and BC. Okay, they are on the same base and lying between the same parallels, and therefore area of BDE is equal to area of triangle DEC. Okay, this is result number 3. Now my friend, we are able to prove that area of BDE is equal to area of DBC. So from result from 1, 2 and 3, we are able to prove that AD upon DB is equal to AE upon EC. Because from the result number 1, 2 and 3, we are able to prove that left hand side of both the results are same. Area of AD is equal to area of AD. It is clear, but the denominators are different. But in the result number 3, the denominators are same. So left hand side of both the results are same. as per 1, 2 and 3. So their right hand side must be same. So hence proven that AD upon DB is equal to AE upon EC. Okay my friend, very good. Now theorem number 6.2, कॉन्वर्स ऑफ थ्योरम नंबर 6.1. ये थ्योरम नंबर 6.2 है, वो 6.1 थ्योरम का कॉन्वर्स है, यानी उसका उल्टा है. इसका मतलब ये कि वहाँ पे जो गिवन था ये यहाँ पे प्रूव करना है, और वहाँ पे जो प्रूव करना था ये यहाँ पे हमें दिया गया है, यहाँ पे गिवन है. ओके, सो उल्टा है. If a line divides any two sides of a triangle in the same ratio, if a line divides any two sides of a triangle in the same ratio, look at it. Triangle ABC is here, ABC is here, and a line, this is the line. Okay, line. You can draw this type of line, but not required. Okay, so in triangle ABC, DE is the line which divides AB and AE in the same ratio. AB and AC, sorry, in the same ratio. Okay, so we have to write in given that in triangle ABC, a line divides, a line DE divides sides AB and AC in the same ratio. लेकिन सेम रेशियो में डिवाइड करने का मतलब क्या है, आई AD अपॉन DB इज इक्वल टू AE अपॉन EC. D अगर AB और AE को सेम रेशियो में डिवाइड करती है तो जो उसके लाइन सेगमेंट बनते हैं वो प्रोपोर्शनल होते हैं, मतलब AD अपॉन DB इज इक्वल टू AE अपॉन EC. ओके, now we want to prove what we want to prove here. We want to prove that the line is parallel to the third side. Which line? This line is dividing the two sides of the triangle in the same ratio. That's why we have to prove this line DE is parallel to the third side, which is BC. Okay, so we want to prove that DE is parallel to BC. That we want to prove. Okay, that we want to prove. And okay, proof. Now proof. We have to think converse. Now we have to give the proof in the as an indirect proof in which the sentence to be proven does not exist. That means if DE, we want to prove that DE is parallel to BC, then we have to assume that DE is not parallel to BC. Okay, so here if DE is not parallel to BC, then draw a line DE dash parallel to BC. Now we have to draw a line DE dash. Okay, DE was the line not parallel to, it assumed that let the DE is not parallel to BC. So we draw a line DE dash which is parallel to BC. Now my friend, now as per therefore AD upon DE DB is equal to AE dash upon E dash. See, look at it as per theorem number 6.1. If ADB is parallel, AE dash is parallel. This is the line intersecting two sides of the triangle, and it is DE dash is parallel to BC. So as per theorem number 6.1, AD upon DB is equal to AE dash upon E dash C as per theorem number 1. But it is given that here that AD upon DB is equal to AE upon EC. It's a given. So both are AD upon DB is left hand side, AD upon DB is left hand side. So left hand sides are same, so right hand side must be same, and therefore AE upon EC is equal to AE dash upon E dash C. Okay, AE upon EC is equal to AE dash upon E dash C. Now look at it. AE upon EC is equal to AE dash upon E dash C. Okay, so it is only possible when E dash and E coincide. Okay, it is only possible when E and E dash coincide each other. अगर E dash और E दोनों पॉइंट एक ही जगह पे है, then and only then it is possible. तभी ये पॉसिबल है. Means what? Therefore E is equal to E dash. Means AE is equal to AE dash, and therefore E is equal to E dash. We can write E is equal to E dash. Both are same point, and therefore we can write that DE is equal to, therefore DE dash is equal to DE dash. Both are same. Okay, दोनों लाइन सेम ही है, एक ही लाइन है. Okay, but as per construction or assumption, DE dash is parallel to BC, and therefore DE is parallel to BC. अगर DED और DE dash दोनों सेम लाइन है और DE dash तो पैरेलल है, हमने यहाँ पे एज्यूम भी किया ना, DE is not parallel to BC, then align DE dash parallel to BC. लेकिन DE तो E dash तो पैरेलल to BC है और दोनों सेम लाइन है, तो DE भी BC को पैरेलल होगी. Okay, now result theorem number 6.1 and 6.2 are converse of each other. एक दूसरे के उल्टे हैं, और ये दोनों बहुत इजी भी है और बहुत ही यूजफुल भी है. आपको नेक्स्ट इस चैप्टर में बहुत सारे क्वेश्चन में इसका हमें यूज करना होगा. सो गो ऑन लर्निंग इट अगेन एंड अगेन, एंड इफ यू वांट टू लर्न द थ्योरम्स देन यू हैव टू राइट इट मेनी टाइम्स. ओके, आपको क्या करना है, दोनों थ्योरम को बारी बारी, पहला 6.1 थ्योरम आप ले सकते हो, उसको 5 बार लिखो, हर दिन 5 बार. ओके, सो 5 दिन तक 5 बार लिखो. राइट दिस थ्योरम 6.1 5 times. Then when you confirm that 6.1 theorem is memorized by you, then start learning theorem 6.2 5 times each, for 5 days, and you will be able to learn both this theorem, because both these theorems are important for board examination. Okay, so I hope you will learn it as I taught you. Okay.